Today we will be studying about principle of complementary stresses. Yes, right? Okay. So, so now we have seen that all the stresses act in pairs, right? The normal stress, it sigma yy. Let me draw the coordinate system first. Y, x, and just see. This is my coordinate system. Sigma yy, sigma yy. And as I have already taught you in the representation of vectors, that this y, second y, represents the direction of stress. First y represents the direction of normal of the plane on which this stress is acting. This plane, normal to the plane, is in the y direction. Okay, so moving ahead, so these are two stresses which act, and then there is one more stress which we studied, that is the shear stress or the tangential stress, which is denoted by this, like this. So this is tau. This acts in the x direction and is the normal is in the y direction. Tau yx. Okay. Now this shear stress, okay, this is the principle of complementary shear stresses. Okay. Now, if in this point element this stress is acting like this, then this point element will tend to rotate in the clockwise direction, which doesn't occur essentially, right? So there has to be some moment opposite to this clockwise tending moment due to this pair of shear stresses which try to rotate this point element in the clockwise direction. There has to be something which is opposing this, right? Otherwise this would have been rotated. The body would change its would keep rotating, right? Has to be some force which is opposing this pair of forces, this pair of stresses, so you can say. So that is known as the complementary shear stress, which acts in the opposite sense to this already acting shear pair of shear stresses. So this can be denoted as tau. The direction in which it is acting is y, and the plane in which it is acting, its normal is x. Okay, is in the x direction, tau xy. Okay, this is stress. Okay, tau xy. Now these are tau yx and tau xy are known as complementary shear stresses. Okay, so what does principle of complementary shear stress tell? Principle of complementary shear stresses tells us that the shear stress always acts in two pairs, not one pair. If there is one pair of shear stress present, there is always one more pair of shear stress acting in opposite sense in a plane that is perpendicular to this existing plane. So this shear stress is acting in this plane, then the complementary shear stress will act in a plane perpendicular to this plane, right? This is the first plane, the complementary shear stress acts in the second plane, which is perpendicular to the first plane. Okay, so this is the principle of complementary shear stress.